So if we have this reaction, we're going to have fuel plus oxygen equals carbon dioxide and water. That is commonly known as a combustion reaction. So if you ever see something where you're adding it to oxygen and you're getting water and carbon dioxide, you should be thinking this is a combustion reaction. And there's something very important that this will tell us about. If we look at our formula, there's a couple of key observations. So we know that all of the carbons have to come from the fuel, right? Because if you look at our products on this side, there is no carbon inside of the oxygen. And also there is no hydrogen except for here, and therefore the hydrogen has to come from the fuel. So basically what I'm saying is that all of the carbon and hydrogen that we have in our products has to come from the fuel because it can't come from the oxygen. So if we have 22 grams of fuel and we have 36 grams of water and 66 grams of carbon dioxide, the first thing we would do is find how much carbon we have in our fuel. And the way that we would do that is figure out how much carbon we have in the CO2. So we would figure out how many moles of CO2 we have. So CO2 is normally going to be what for our molar mass? Right, it's going to be 44. Whatever, this is not going to work. Right, so carbon dioxide is going to be 44. So if we divide 66 by 44, we're going to get a mole and a half of carbon dioxide. And if we look at the actual formula, we have 1 mole of carbon in every mole of carbon dioxide. Because if we look at the formula for carbon dioxide at CO2, there's only 1 carbon atom in there. So if we have a mole and a half of carbon dioxide, by default, we have a mole and a half of carbon in that. So how many moles of oxygen would we have in carbon dioxide if we have a mole and a half of it? We have 3, right? Because if we have a mole and a half of carbon dioxide and there are 2 oxygens in every carbon dioxide, then we're going to have 3 moles of oxygen in a mole and a half of carbon dioxide. So back to the actual problem. If we're trying to figure out the formula of our fuel, if we have 18 grams of carbon, that means that we have 18 grams of carbon in our fuel and in our carbon dioxide. It's going to be the same number because of the conservation of mass. We can't get rid of the carbon if the only 2 places we can find it is in the CO2 or in the fuel. And that goes the same thing for hydrogen. If we can only find hydrogen in water or the fuel, then the amount of hydrogen that we have in water has to be the same amount of hydrogen that we have in the fuel. And if we do our math with the 36 grams of water, we know that water weighs roughly 18, which means we have 2 moles of water. And if we have 2 hydrogens in every mole of water, and we have 2 moles of water, then that means that we have 4 moles of hydrogen. Does that make sense to everybody? All right. So then our next step would be taking both of these numbers and then finding the lowest whole number ratio that we can combine them in. So in this case, our lowest whole number ratio is going to be 3 to 8 because we multiply 1.5 times 2 to get to 3. We multiply 4 by 2 because we multiply the other one by 2. We have to do the same thing to both of them. And we're going to end up with C3H8. So it's commonly known as propane.